All right, hi everyone. Welcome to the React Native webinar. My name is Neil, and joining me is Andrej, and we are senior JavaScript developers here at Rangle.io. We're located in Toronto, Canada. We are the leading JavaScript and lean UX firm, and our mantra is that we help startups and enterprises move to the modern web. So we typically build applications in AngularJS, React, Ionic, and React Native, and we have a continuous delivery process. So today we'll be talking about React Native and its benefits. So React Native, why choose React Native for your next mobile app? So today we're going to argue why we believe it is the right choice. Just a quick overview of what we're actually going to be talking about. So I'll give you a brief overview of React and its benefits, then dive into what is React Native, and then discuss why we choose React Native, and finally wrap up with a question and answer session. So what is React? React is a JavaScript library built by Facebook. It was first released in 2013. The current version is 0.14, and let's discuss what makes React great. So React is a JavaScript library for building user interfaces. So library is the keyword there. It's not a framework. It does not provide the bells and whistles that something like Angular does. It focuses on one thing and doing that one thing well, which is building components. So if you've ever used Angular previously, it's similar to building directives in Angular, except we use JSX syntax rather than templating to build HTML tags. So React is concerned with just the UI. So it's only the view. So there's no assumptions about the tech stack that you use. You know, you could use model view control pattern, you could use something like Flux, something like Redux. This allows for a lot of flexibility. So you're essentially allowed to choose whatever you want, whatever you're comfortable with, really. The key is that you're building components. So components. Components can be defined as, reusable pieces of application components that define your brand. So essentially in React.js, they wrap the DOM's API and transfer your code from being imperative to declarative. So code is more predictable, and in an agile methodology, it actually allows for quick iterations. So if you think of, we build a button component, and then we compose those components together with, say, a modal. Once we decide that we want to change the look and feel of that button, we just change it in the one place, and that's reflected all across every view you use that component in. So let's look at a simple component. So here we have like a hello world component, and essentially what it's responsible for is rendering a simple div with hello and then the provided name. So mind the ES6 syntax, but essentially this is just a simple function that takes in the property name and then renders that div. So JSX essentially allows us to do HTML and JavaScript, and data flows in and then is rendered to the DOM. So this is actually a really powerful abstraction. This is sort of a representation of a simple building block, and these building blocks is what you build your brand from. Then you compose them together to create new components. So that last line there, React DOM.render, is very specific to the React.js library. Essentially there we're saying we're going to render this in the browser's DOM. And you can see we use the new hello world component and inject the name Rangle.io in there, which is a string, and then that'll flow into the component and render out. The body node there just represents where we're going to actually mount that component. It's typically something like document.getElement by ID, with the ID of root. And that's typically found in your index.html, something like that. So this is simple and declarative, right? Components essentially express how the app should look. React then automatically handles changes to the UI and reflects that. The nice part about React is it only updates the parts that are changed, so you get some awesome performance as a result. And so you get one-way data flow, a reactive data flow. And this is easier to reason about, it's easier to debug, it's easier to build new features. So properties flow down, such as the name Rangle.io there. And then we also have actions, and actions actually flow up. So for a bit of a trivial example, but we would have a callback that we provide to that component, and maybe when you click a button, maybe it takes a string and makes it uppercase. So when I say actions flow up, what I mean is it goes back into wherever that state is stored, and then something would cause it to become uppercase, and then those properties flow back down into the component. So React.js also has the virtual DOM. And what the virtual DOM is a DOM abstraction. So we can think of, given a specific application state, React will render a visual representation of that state. So there's a lot of performance improvements here. But it also gives us the ability to render on the server or even render to native components. So with that being said, then what is React Native? So React Native is a framework for building native apps. It's everything great about React, but applied to native applications. It was released in early 2015. It's currently in version 0.17. It has iOS support. Also has Android support as of September. Android 4.1 is supported, and iOS 7+. And so we essentially are able to write React components that compile down to native components. So instead of thinking in terms of divs and spans, which we have with the DOM, we render views and text components. So the nice part about this is we're able to develop efficiently. We can use the same approach that we use in React.js, but apply it to native development. So learn once, write anywhere actually becomes a reality. So why do we do native, though? I mean, native is difficult, right? Native programmers are hard to find. Native programming is expensive. It's hard to maintain. It's hard to lay out. Development is slow. You need to compile every change. Like, why do we put up with this? And the reality is because we want a better feeling experience, right? We want the user experience of native. So native is necessary. Developing native apps is expensive. It takes longer, it costs more. We get native-specific components, date pickers, switches, navigation, maps. It's possible to re-implement this stuff on the web, but it never feels as good. As well, web views tend to have poor mobile gesture recognition. There's no sophisticated threading model. Yes, we have web workers, but it's not the most ideal situation. But with React Native, we get the best of both worlds. So we want the user experience of native, but we also want the developer experience of web. So yes, we could use web views, but there might be performance concerns at some point. And with React, there's no coupling to the DOM. We can use the power of React to render native views. So why we choose React Native? So React Native is an extension of hybrid. React Native's biggest feature is React. We can develop in the same way that we do for the web, use the same approach, even share the same components with web. We can develop once and deploy on iOS and Android. It's not just a JavaScript library, it's an approach to building interfaces that is declarative and simple. So React Native components are extensions of standard platform components. What does this actually mean? So React components are backed by native components. In React Native, we have date picker and inputs and switches, and these provide a consistent look and feel with your ecosystem. It also keeps the quality bar high. Unfortunately, not all components are available. An example is UI table view, but there are open source projects that are working on implementing these. The reality is, though, is a lot of apps can be built with the prepackaged components that React Native provides. So another big feature is obviously developer efficiency. There's no context switching. You know, we're only writing in JavaScript. We can use CSS for layout, so we can transfer all of our CSS skills over to React Native. We get hot loading changes, which provides a feedback loop for our developers. You know, develop it and see these changes immediately. And we can also deploy on Android and iOS. So we can use the power of Flexbox and CSS. Again, our previous CSS experience can be leveraged. In React Native, essentially what's happening is style properties are converted into native view properties. The nice part about this is we don't need to learn a new layout engine. We can even use our designers to write essentially what is CSS for our React Native components. So converting existing layouts over to React Native is not all that difficult. And React for the mobile web. So gestures are more complicated on native. You know, it really makes or breaks the experience. So React Native actually has an awesome gesture responder system that allows us to create the complex interactions that we're used to seeing on on native applications. And this is not easy to do in a web view. React Native is also extensible. So you don't need to write native code, but when you do need to, you can. You can also reuse anything that you've previously written. So niche libraries or custom native code. There's lots of tutorials on the Facebook website for actually doing this. So when you actually need to pop into Objective-C or Java, you totally can. So native look and feel. Like that's ultimately what we're striving for, right? We want that 60 frames per second. We want smooth UI interactions. It's totally possible in a web view, but it takes a lot of work. And with React Native, we kind of get this out of the box. We don't need to cut so many corners in order to make our app entirely performant. Ultimately, though, I believe that React Native's killer feature is the fact that you're using one framework, right? No context switching. We develop in the same way for web and mobile. And the key there is we get the user experience of native with the developer experience of web. So React Native uses polyfills to leverage the best of the web. So for example, Flexbox, Fetch, geolocation APIs. These don't exist on native, but they do in the browser, and they're very familiar tools to our developers. So it's easy to transition over to React Native development. Flexbox and CSS. So here's an example of how we would style our React components. This is familiar CSS code. You know, we don't need to learn new layout engine. It allows our design team to implement CSS quite easily. Geolocation, so this is the same API as a browser. It follows the web spec. It's familiar to anyone that has used geolocation previously. For fetching resources, we get Fetch. So this is built by the standards committee. It's completely implemented in Chrome right now. It's much simpler than XHR HTTP requests. It's promise-based. But we also get WebSockets, which are nice. So if you want to do real-time communication, that's totally possible. And then we also get a polyfill for all of our timers that we're used to seeing in JavaScript. So set timeout, set interval, request animation frame. We can use the same way that we use them in the browser, and they obviously allow us to perform asynchronous execution. So I'm going to pass it off to Andrej now, and he's going to keep the discussion going.
Hello everyone, my name is Andrej. Thank you for joining us today. Basically, I will be talking about the tools that we use for developing mobile apps with React Native. The first and most important tool is NPM, which we're going to be using for cross-platform dependency management. As you can see in those two lines that I have in the slides, we have npm install and npm run build. JavaScript web developers have been using this throughout their projects for installing their package that are dependent, that their application is dependent on, and for building their application. By building, we mean minifying, uglifying, or perhaps even transpiling their code. So it is a great thing that we can take this tool that we've been using for our web applications and use it for creating mobile apps with React Native. The benefit is that, as we already mentioned, that most of the web developers already know this tool and know how to use it, and there's no need of learning any new tools for specific platforms. So let's take a look at the package.json configuration file. In the first few lines, we have the name of the project, the version, and whether it's private or not. And then we have the scripts that we can execute for our project. In this particular case, we have start, basically, which enables us to start our application, which would basically fire React Native command and execute our application. Then we have dependencies, which is a list of our packages that we need for our project. And in this particular case, we have React Native. This is an example of how we would have a React Native app. But also we can have something like this. We can have React DOM as part of our dependencies, mainly for having one code base which would contain the React Native code and the code that's going to be running on the web. So NPM is a common tool across all the mobile and web platforms, and this is way better than learning different schemas and declarations for each platform. For example, in the Android world, we would have Gradle, and it's a great and powerful tool, but we would have to learn how to use it, and then we would have to use the equivalent for iOS, which is CocoaPods. So let's take a look at other web development tools, which are the same tools that we've used for web development and that we can use in this React Native world. So for developing native iOS or Android, we're usually bound to using Xcode or Android Studio. But most of us, the web developers that have been using JavaScript, we want to have freedom of choosing our editors. And basically, for creating your mobile apps with React Native, you can do the same. You can use any IDE, such as Atom, Vim, Emacs, and whatever you prefer. So then we have debugging. In the web world, we normally use our browser environment to do our debugging, and Safari, Firefox, and Chrome, they have their own debugging tools. And imagine using that same familiar tool for debugging your mobile app, and that's pretty much doable with React Native. Currently, we only have Chrome Dev Tools available for using with React Native, and we can also install the React Dev Tools extension that can help us inspect all these native components of our application. And we also have a second option, which is debugging our application with the Android or iOS emulator. And as you can imagine, setting a debugger statement or creating a breakpoint is as easy as you would normally do in while developing a web application. IDE or code editor, I've already covered this. Basically, we have the freedom of choosing any editor. We can keep the same settings and plugins or extensions that you already have installed and set up on your favorite code editor that you've been using for developing web apps. Also, we can use pretty much any JavaScript library as long as it does not depend on the DOM or any core node APIs. Libraries are very useful. They're packaged solutions that we can use in our projects, and we're free to use any of those. For example, we can use Lodash, Lambda, Immutable.js, Bacon.js, RxJS, and so on. Leverage existing JavaScript business logic to speed up time to market. So we already talked about how React applications are composed. So they're basically consisted of view components and some business logic. The business logic is basically pure JavaScript. It has no dependency of the DOM, and also it does not depend on any native components. The business logic is usually a code that runs exactly the same on every platform. So therefore, it can be reused across all these platforms that we're developing on. The only thing that we need to make sure is to keep them separate from the views, perhaps into modules, into separate modules, or utility functions. So we have this learn once and apply anywhere motto with React Native, and this is different than write once and use everywhere that we have in the Java world. The reason we learn once and kind of have to write separate code for separate platforms is really because there's few differences between those platforms, and they should be treated differently. So basically, we should still be developing discrete apps for each platform, but we end up having the same group of developers for whatever platform they choose to develop on. The developers don't really need to learn fundamentally different set of technologies for each platform. So basically, they can reuse as much as possible of the code that they develop for the web platform for the other platforms that they're supporting. So what do we mean by learn once? Basically, we mean that we only need to learn two things. The first thing that we need to learn is React and the React principles and how to build React components and how to put them together into an app. Also, then we need to learn the React native specifics, such as native components. And the good thing is that most of those native components are seamlessly cross-platform as well. The second thing that we need to learn, and most of web developers already know this, is CSS and Flexbox. If we're careful how we use this, we can use pure CSS Flexbox, which can be pretty much reused because it's cross-platform. Also, we have the business logic code, which is shared among platforms. And the only difference that needs to be considered is the view components, which are basically unique to every platform. So let's consider the following scenario. We have a company, and the company is supposed to create an app for several platforms. So we have two options. The first option is have dedicated team for creating the web app and few other teams that will develop the mobile app. And then the other option is have one team of JavaScript React developers which would maintain a single code base. So for developing software, we have a software development process. And if we choose the first option of having each team dedicated for every platform, that means we have to have a separate process in place for every platform and maintain separate code base. So having a single code base is more important for having more efficient process and not just saving cost. A single code base is really beneficial to startup companies because normally startup companies have few developers, therefore limited resources and limited ability to learn. Also, it's beneficial to startup companies because they can easily prioritize and find their product market fit. This single code base would allow the company, your company, to drive waste out of your scope, increase user value, and reduce costs further. Also, it will help ship the app on all main platforms before your competitors do. So, why cross-platform is essential for agile lean startup? Agile-based development requires frequent feedback from users about the product software. Also, it requires prioritization of next features. So the developers periodically present a working demo of the app to the users. And then the users come back with some feedback. And that feedback normally is either positive or sometimes it can be negative in a way that it would require some minor or major changes to features that were presented to the user. So having one code base of React, as we already talked about this, it reduces context switching. Hence, it allows the developers to move fast. So as a result to that, the developers are able to ship frequently, and respond quickly to the user needs. And basically, that is what is needed by Agile and Lean Startup. Otherwise, you end up piling features throughout a long period of time and then presenting them to the users at once. That's essentially the waterfall process, and in most cases is not working that well, especially not working well for startup companies. So having multiple code bases would be really slowing down the development team, and having a single code base speeds things up and makes the process more efficient. So now we can get into questions. Feel free to ask anything. We have one question.
So one question here asked was, what are the limitations of React Native? The biggest limitation is that, like anything, it is an abstraction. And with abstractions come some limitations. So if you need to be extremely performant, you will likely have to go down to Objective-C or Java at some point. If you're using niche third-party plugins in native, again, you'll probably have to drop down to Objective-C or Java. The nice thing is, though, is that native is always available. So you don't yourself, like if you get to that point where you actually have a performance concern or something like that, then you can totally take care of that stuff. At the same time, the Facebook team has worked really hard on performance, so even out of the box you get some awesome performance. There's one question here about web views. So React Native isn't in a web view. I was actually just comparing them to Cordova or PhoneGap or something like that. So you are compiling down to native components. So there's one question about how well, if at all, does React Native work with CSS preprocessors and less than Sass. So we don't usually, when we write React Native code, we are usually writing inline styles in the components, so we don't typically bring those over. But the ideas are somewhat shared, so you could port CSS or less than Sass over to React Native. But typically we are styling components individually. So there's another question here about can I use React Native with other common React libraries such as Redux and Lodash? Yeah, so you totally can. The key is to use libraries that do not depend on the DOM. You can also use Node libraries as long as they don't depend on Node core functionality. There's a question about performance, just like, is there any issues with performance? So I haven't seen any, and actually I would say that it's actually extremely performant. Facebook has a couple of demos on the Facebook website for kind of demoing some stuff off. But yeah, I've had a great experience with it. Sometimes, especially on web views, depending on what you're doing, you can get caught up in typical DOM performance issues. So those tend to disappear. Like I'm thinking of an example would be really long lists. That's the sort of stuff that React Native kind of rips through really easily. So there's a question about major surprises that weren't covered in the documentation or examples. I mean, React Native is still being heavily developed. It has only been out since January, so the API does tend to change. but nothing. I mean, even the first time I opened it up, I was able to whip up a small app quite easily. So, and anything that's, I haven't found anything that's like not undocumented to the point where I have to open the source or anything like that. And the community is really driving the push behind React Native. So, but their documentation is actually really good.
So we have another question. Can you implement Redux-like architecture flawlessly with streaming into a React Native app? We are using Redux with React Native, and it's been working pretty good so far. So as I already mentioned, as long as you're using library or tools that are not dependent on the DOM, you can go ahead and use any library. So we've tried Redux, and it works pretty good.
So there's a question about objectives, like I heard Objective-C, but what about Swift? So yeah, React Native, you can totally use Swift. I think I mentioned it previously, but you can bring any module that is written in Swift into React Native. We're just going through some more questions here.
So there's another one. What's the difference in using React Native versus native app and web views? So if you use web views, you basically you're losing the user experience is not that great. I mean, the user can really tell that this is not a native app. So basically, the better option here is to create a native app. But you wanna, like, if you wanna have two projects, two separate projects for one for web and one for native, then you would have to maintain two different code bases. So the good thing is, if you decide to use React Native, you can have one single code base for both platforms, and probably 80% of that code will be shared among both platforms, and maybe 20%, which would be the views and other differences like geolocation or whatnot, would be like the only difference.
How does React Native handle routing between pages? So when you're working on iOS, there's something called the navigator as an example, and the navigator acts essentially as your router. So that's what's responsible for transitioning, from view to view. That's what gives you the back and forth effects of native applications. So I don't want to dive too much into that component specifically, but there actually is a really good tutorial on the Facebook documentation for React Native about the navigator component, and you can kind of poke through there and get a good understanding of it. So just going through some additional questions here. Give me a second. A question about actually structuring the files in our application. So we typically build in like a Redux model where we build containers that contain the application state, and then they pass that state down to our components. We typically follow like a dumb component model. So typically components are static components. And then in terms of how we divide up the code base, so between Android and iOS, there's actually some tricks that you can employ. So if you look at the official documentation under the platform guidelines, you can basically implement the same component twice. I believe you use like a file name extension that'll allow React to pick up whatever it is based on the platform it's on. But yeah, we typically separate our JavaScript core logic, which is our reducers, our actions, and that sort of stuff, and then components sit in their own folder, and containers will sit in another folder. So there's a question about how do you compare Ionic with React Native? I mean, Ionic is a web view, obviously, so and it's also based in Angular, and then React Native is obviously compiling down to native components. So they're very similar, but a different approach, I guess. One thing that the Angular team is looking at doing is something similar to what React is doing because of the component-based architecture of Angular 2. So I wouldn't be surprised if we see a push from Ionic to go to a more React Native kind of model. But ultimately, yeah, you're working in a web view still, so you can hit some performance problems. Off the top of my head, one big thing I noticed is in Ionic, when you get long lists, especially with images, you start having to do tricky things to get those to render really nicely, whereas React Native tends to not have those sorts of problems. And when you're working in Ionic, obviously you are in a web view, so you can go right into Chrome and debug your app, whereas in React Native you are working through the inspector. So a bunch of differences going on there, but the key point is you're working with native components versus a web view.
So there's another question. What would you consider a smart component? So basically we have two types of components, and when we build an app, some of those components are not really aware of the state of the app or their own state. So those are the dumb components, the simple components, and the other components that have state, or perhaps if you're using Redux and you kind of have to connect the store, the Redux store, to those components in order for the component to be aware of those store values, or the state of your app. Those components are considered to be smart.
So there's a question about sample Git repos. The one I always recommend is actually the official one. They've got an awesome little app that kind of whips through all of the components that are included with React Native, and you can get that just off of the official documentation. That's probably the best way to get into React Native specifically. Yeah, I think that's it. There's a question about examples of popular applications using React Native. So recently, again, Facebook added to the React Native repository or the documentation some examples of popular apps. Off the top of my head, Facebook originally demoed this in the Facebook Groups app. So that's definitely one where it has React Native components to it. Another one is that I know of is Discord. They also built their app in React Native. But they have a great little list of all these apps that have been building in React Native on the official documentation. There's another question about how does design play a process in our React Native apps. So our designers typically design the small components of our React apps, and we also have them doing the inline styling. And the way that we typically build our components is, again, DOM components, and we use those small building blocks to then be composed with other components to then create larger components. For an example, a button component, an input component, those are the building blocks of a form component. And so what our designers are typically responsible for is actually writing the smaller components and then styling them. So they build the brand of our React Native applications. This is also true for React.js as well. And we found it's actually an easy transition over to Angular from React because there's a little bit of JavaScript going on there, but typically it's still just CSS and HTML. In React Native, you are using components, but we can at least wrap our designers' heads around that. Okay, we're just going to wrap up now. Thank you very much for all the questions. If you have anything else, feel free to reach out to us on Twitter. Yeah, thank you.
Thank you very much.